Good morning, everyone, and welcome to day 2 of the Jefferies Conference. We'd like to thank you all for your participation in this year's event. It is my pleasure to introduce Erez Zimerman, CEO of Massivit 3D Printing. And with that, I'll pass it over to Erez.
Thank you, Connor, for the presentation, for presenting me, and thank you so much for the opportunity to present in Jefferies conference. My name is Erez Zimerman, and I'm from Massivit 3D. I'm located in Israel, and today I'm going to talk with you about transforming industries to large format additive manufacturing. Before we start my presentation, you see here, you can see a glass of water, in which I take a small sip. But more than that, what I wanted to show you is that I'm going to take a small 3D printed part, and I actually gonna drop it into the water. I hope that you can see it over the Zoom properly here. So I just drop a small part of 3D printed part that was printed with one of our machines. Unfortunately, nothing happened, and nothing will happen in the next 10 minutes. I'm not gonna have the vaccine for the COVID-19, but I'm gonna have something very interesting for you to show from this glass in about 10 minutes. Without further ado, allow me to introduce a little bit the company. Massivit founded in 2013. We are 60 employees around the world, in Israel, in our headquarters, and in some other places in the world. Our technology is baked with 57 patent assets, and we already sold more than 140 units of the Massivit 1800 product. Our product is a large-scale 3D printer that's capable to print 4 feet by 5 feet by 6 feet tall. These are industrial 3D printers, again, that capable of printing in large volume, in large scale. Our printer capable to print in radical speed. When I say radical speed, I mean that we can literally print at least 30 times faster than any other technology that is available today in the market, and all of it baked with patents that we have. And another benefit that we have of our technology is the fact that we are printing without any support structure, and there is no need for any waste or any other things that you need to waste because of the printing process. And with Massivit, the object is come out of the printer as is. Some of the use cases of our 140 customers that we have around the world that are using our machine. This is an example from the events and entertainment industry. You can see the Adidas shoe that was 3D printed with Massivit in a matter of hours, and then it was decorated with color. We can see on the industrial segment from the automotive industry, a full car that was 3D printed in 2 weeks only. This is a 15 feet long car that was 3D printed. This is another example from the advertisement industry in Italy that was the eagle was 3D printed for Imperio billboard. And another example from the industrial industries is the marine. Here you can see the captain cabinet that was 3D printed and actually used in a yacht. So this is all about us, and this is the present. And now let's talk about a little bit about the future and where Massivit is aiming with our disruptive technologies. Now, before I get into the details, I just want to talk to you a little bit about composite material world. I'm sure that you all heard the name composite material, but when we say composite material, just to give you a little bit background, composite material is actually a combination of two materials, which the combination of them make a third material, which is mechanical properties are significantly stronger, lighter, stiffer, and more flexible than the two core materials that we mix together. A very famous composite material, I'm sure that you heard about the carbon fiber. Carbon fiber is used in the automotive industry. I'm sure that you all heard about bikes that are being manufactured from carbon, and this is material that is 5 times stronger than steel and stiffer and much, much lighter than steel. Another famous example of composite material is the fiberglass. Here you can see a speedboat. I'm sure that you also surfboard. This is also very common composite material that being used in many industries. Now, when we are using composite material, few of the industries are, for example, automotive, marine, the yacht, catamaran, surfboards, consumer recreation, construction, infrastructure, aerospace industry, defense and ballistics, and renewable energies. I'm sure that some of you have seen the huge wind turbine that actually generate energy from the wind. Now, just to give you some more examples on the motivation to move to composite materials, here we can see the Boeing Dreamliner, the 787, that is actually made of 53% composite material. The motivation to move to composite material is, of course, saving fuel. The lighter the aircraft will be, the longer mileage the aircraft can fly. Here we can see another example from the automotive industry. This is a BMW i3 that is actually lightweight and being produced from composite materials words. The BMW i3, you can see here, two people lifting the passenger compartment. You can see how light it is. Of course, the motivation here for the car industry, that the car will be lightweight. This is an example for an electrical car. Now, in order to, once you have a lightweight car, you can gain more mileage with the same battery that you are using today, and the motivation is to move to composite material. So just to give you some background, I hope that you can see, this is a part of a car. I hope that you can see here in my Zoom camera that you can see the part. This is a car that made of carbon material. And this is the carbon fiber. This is the carbon fiber as the raw material. Now, in order from getting to carbon fiber to a final part, I will need a mold. This is a mold. This is a mold in which, with this mold, I'm creating the 3D, the composite material part. Now, what we are doing, I'm taking the mold. I'm just trying to make it simple as is on the technical side. We're taking the mold. We apply the carbon fiber inside the mold. We sponge it with epoxy resin. We put vacuum on top of it. We let it to lay out for 12 hours. And then we have the final part that I just showed you. Just to emphasize that this mold is a complex process in which manufacturers do today with traditional techniques. The dominant one is a CNC machine. And once you want to produce parts from composite materials, the biggest bottleneck is the mold manufacturing. To manufacture the mold is extremely slow and expensive process due to several reasons. The first one, mold making is a very complicated process that includes 19 steps. Sorry, most of them are manually. It's expensive to produce these molds. You need highly skilled employees or operators to produce these molds, and it takes quite a while, and it's a very time-consuming workflow to produce the molds for the composite material market. Now, the composite materials mold market is huge. In 2020, companies will spend $4.3 billion on producing molds. I repeat, companies will spend $4.3 million on producing the mold, very similar to what I have in my hand. Some of them are bigger, some of them are smaller, but in order to have parts, they will spend $4.3 billion producing molds. Now, what Massivit is developing is a disruptive technology for the composite material world that actually gonna change dramatically the industry, and you're gonna see our technology in a minute. What we're actually developing is a 3D printer that will be capable of printing these molds in very, very fast way. Let's have a look on our technology. Allow me to switch 1 second. I hope that can you see my screen? I hope that you can see my screen. Well, give me 1 second. Okay, so I'm going to present you in this movie clip our MTB. MTB is acronym for Massivit Tool Builder. This is a 3D printer that will print mold for composite material. What you can see here, this is the MTB Massivit Tool Builder, and inside this is a 3D printed part. It's actually a mold for a car seat that is made out of cardboard. Let me show you how our technology works. What we are doing here actually, we are taking two heads that were developed by Massivit, and we are actually injecting two walls. We call it a sandwich. We're injecting two walls that done by the left hand. We call it the print head, by the printer that you see here. And in between, there is a dispensing head that actually inject castable material. Now, what we are doing, we are printing a sandwich and we are injecting a castable material in between this sandwich. I understand there is some delay in the movie, so I will wait another second. So you can see the head, and here it is. Yeah, I have some delay. So here again, you can see on the left side, this is the printing engine that building the walls of the sandwich. On the right side, you can see the dispensing head that actually cast on the fly casting material. Let's see how it works. I will be wait 1 second to see that you be able to see the sandwich, as I call it, and the casting material in between. This is again the sandwich, and another head, which is dispensing head, injecting the casting material on the fly. After the completion of the printing mold, we're actually taking the part and actually put it in a simple tap water. We put it in a simple tap water, and then the walls collapse. And actually what we call water breakable material, the walls falls, and I'm having the mold as a final result. I will go back to the presentation. Now I hope that you can see this properly. Again, this is the same mold that I just showed you, okay? But this is the mold, okay? And this is the 3D printed mold. If you look carefully, the white walls are the water breakable materials, and the blue material here, this is the casting material. What we are doing after the part was 3D printed, the mold was 3D printed, I'm just dipping it into the water, and the walls are fall apart, and then I have the final mold that you have over here. And this is a disruptive technology that we developed, and instead of 19 steps, we're doing it only in 4 steps. Now remember that about 10 minutes ago, I throw a piece of 3D printed part to the water just to show you. I cannot do a full demonstration. So if you look carefully here, the part that I drop inside is falling apart. It does not contaminate the water. This is a totally green solution. We are not contaminating the water, and this can be used very nicely as environmental friendly material. One second. Now, after we developed the technology, as you've seen in the movie, we developed the printer, the Massivit tool builder. It's an additive manufacturing system that actually produces large-scale molds in a record speed and a friction of the cost. The MTB is based on our legacy line, which is called the Massivit 1800. And our main benefits is, as I mentioned earlier, we are dramatically changing the process of composite material manufacturing. And instead of 19 steps, we are doing it only in 4 steps. We dramatically reduce time to market for end-use parts. For example, in a yacht, there's about 100 molds that are today being produced by CNC machine, and all this mold manufacturing will be shifted to 3D printing. We are lowering the production costs. We are producing large-scale molds in a size of 5 feet by 3.7 feet by 5 feet tall. We enable construction and actually to create a complex and creative geometries. And this is an environmentally friendly, minimizing use of materials. Again, we are using additive manufacturing versus abstractive manufacturing. And everything is controlled by a mouse click, and it reduces the dependency on high-skill laborers and operators. This product creates a very unique value proposition in which it cut 80% in production time, 90% in labor cost, and 50% in costs. We see a very strong market demand for this product, and we already have a 5 contingent purchase order and continue to growing and having ordering and interest in this product. We started the pre-sales and we have already 5 contingent purchase orders. 2 customers are from the US, 1 is from UK, 1 is from France, and 1 is from Taiwan. Let's see what our customers that adopting our technology already doing with it. Here is an example of the car seat, very similar to what you've seen in the video clip. On the top left side, you can see this is how it was 3D printed. It was dipped into a water, and then they put the carbon fiber on the left side on the mold, and on the right side, this is the end use part. This is another interesting example from a Catamaran that that printed the mold for the hydrophil, for the fin. And we are looking more and more into the future. And our vision is at the end to print end-use parts in large scale, for example, like furniture that can be 3D printed, architecture, and of course, renewable energy, which is a very, very important segment in the future that the world will be shifted to renewable energy. So thank you so much for your time. I will be happy to meet you later on one-on-one and share with you more information about Massivit, about the company, and also on investment opportunities with Massivit 3D. And thank you again. If you have any questions, I will be happy to answer.
Great, thank you, Erez. We'd now like to open up to the Q&A portion of the presentation. So if anyone in the audience has any questions, please enter them through the Wall Street webcasting app. We don't have any questions at the moment, Erez, but perhaps you could give us a little bit of your strategic views on the 3D printing market in general, kind of where the industry is going from a macro perspective to start the Q&A off.
Thank you, Connor, for the question. First of all, I think that what we can see today that the 3D printing is penetrating more and more to markets. We can see, you know, if you ask people 5 years ago, what is 3D printing, people were not aware. And today, people and students, and even in elementary school already learn what is 3D printing. And I think this is excellent. I think that in the future, one of the barriers of 3D printing, there are 2 main barriers. The first one is the printing speed. If you had a chance to look on the 3D printing, you know, you're looking on a 3D printing, you see it's built layer over layer over layer over layer, and it takes hours, if not days, until you have a final part. And this is where Massivit develop our technology, in which we print at least 30 times faster than any other technology. And this will enable more and more companies to adapt on the industrial side 3D printing. I think this is one barrier that 3D printing have, and Massivit brings a solution. Another barrier that is still in the market for 3D printing is the end-use parts. Today, people expect to have parts that come from 3D printing with the final mechanical properties, and this is something that we are looking on, and we are working on solution like the MTB printer to bring something that you can use well-known material that already have the certifications in the market, so you can start utilize 3D printing into your final production. So I hope, Connor, this is address your question.
Yes, it does. Thank you for that. And then the next question I had is, you mentioned some of the longer term end markets being, renewable energy, architecture, furniture. How far into the future do you think that a 3D printing solution would be viable for those end markets?
From my point of view, I think that we're talking about manner of 2 to 5 years, I believe. Imagine that you want your own sofa that will be tailor made, let's call it this way, to your house, and your wife would like to have a very nice decoration on it, and this can be 3D printed. Think about stock level. Companies, instead of cutting woods and have stock of wood and stock of furniture, you will get into a store, said, okay, I want this chair, and after 20 minutes you can pick it up from the cashier. Imagine that instead of having woods and everything, you will just have a pail or a bucket of 3D printed material, and it will, again, the speed and the material will be available in the coming years, and you just can pick it up. No need for transportation, no need for storing, no need for anything. The value of 3D printing is enormous.
That's awesome. Well, I believe those are all the questions that I had, and I don't see any from the audience here. So I think we can wrap the presentation up here. I'll give you an opportunity for any final words.
Yes, first of all, again, thank you for the opportunity to present at Jefferies conference. I will be, if people want to have questions later on, you can have my email below. It's erez@massivit.com. Feel free to drop me an email, and I'm sure that I will be happy to address any question in the future. Great.
Well, thank you very much for your participation in this year's conference and for the presentation. And with that, we can end the presentation here. Thanks again.
Thank you so much. Thank you for everyone.